Take a look at some more examples at integrating inverse trig. So let's say we had the integral of dx over the square root of 4 minus x squared. So just like before, if it's a polynomial denominator, complete the square, but if not, ask what it looks like. So looking at all the options that we have, it looks like that. So we're going to write that down. So the integral of 1 over the square root of a squared minus u squared du is arc sine u plus c. And the key is to make it look like that. So factor out the denominator if a is not equal to 1. A is not equal to 1, so we do need to factor it out. So how do we factor that out? We'll take out 4. If we take out 4, what's left? 1 minus and then x squared over 4 because we've taken out 4. Now, I'm just going to show you this with numbers, then do it with this. If you had the square root of 16, you know it's 4, right? Which is 4 times 4, which you can rewrite as the square root of 4 times the square root of 4 because that's going to be 2 times 2, which is equal to 4. So it's the same thing. So I can rewrite this as the square root of 4 times the square root of the parentheses. This is a listening check. Circle example 2. Once I know that, I can take the square root of 4, which is 1/2, put that outside, leave everything else inside, and now my a is equal to 1. So once my a is equal to 1, I can rewrite it squared terms. So u squared is equal to x squared over 4, which means u is the square root of both top and bottom, which is x over 2. And a squared is equal to 1, which a is equal to 1. That's perfect. So you got 1/2 is the square root of 1 squared minus u squared, which is x minus 2 squared. X over 2 squared, I'm sorry. And then dx. Find du in terms of dx and make it look like what you need. So du is equal to 1/2, because x just goes away, dx. And that's what I need, actually. So I've already found out what I need. Rewrite the integral in terms of u and du. So the integral of 1/2 dx is going to be du over the square root of 1, because 1 squared is 1, minus, and then that is u squared, because u is x over 2. Alright, so that looks exactly like that. So now we can say that the integral of that is arc sine u plus c, and u is equal to x over 2 plus c. That's pretty much it. So take a look at another example. If it's not a polynomial on the bottom, alright, just go to straight asking which one does it look like. So that one looks like this. So we're going to write that down. And that's equal to arc secant u plus c. So we need to make it look like that. Alright, so factor out the denominator of a is not equal to 1, which it's not equal to 1, it's equal to pi. So let's factor out pi. That leaves x squared over pi, because they didn't have it. And then we take the pi out of there, it's been 1, no, negative 1. So that's going to be the same as the square root of pi x, and then the square root of x squared over pi minus 1. This is a listening check, box example 3. So u squared is equal to x squared over pi, which means u is the square root of x squared, which is x, and the square root of pi, which is square root over pi. And then a squared is equal to 1, and that means rewrite it as squared terms. So it's going to be 1 over square root of pi outside, and then that's x, and then the square root of u squared, which is x over radical pi squared, minus a squared, which is 1 squared, and dx on top. Alright, then find du and make it look like what you need to in terms of dx. So du is equals to 1 over radical pi, which is going to be a straight up substitution. So write the integral which is going to be du, because all that has become du, over x. So I need to find what x is. Okay, so all I have to do is multiply both sides of that by radical of pi, which is going to be radical of pi u equals x. So that's what I'm substituting x as. So x is radical pi u, and then the square root of that, which is u, so that's u squared minus a squared, or 1 squared. Alright, and that looks just like that with the exception of that radical pi, so I'm going to take that outside. So now that looks exactly like that, which means that's arc secant u. So this is going to be 1 over radical pi, arc secant u plus c. Alright, substituting u back in, it's going to be arc secant, and u is x over radical pi.